Okay, this is the video tutorial for the CAM portion of the MONIKER um, file, so project. So you'll be doing some CAM work on your very first um, project. So open your MONIKER file. Hopefully you've got open shapes like this that can be cut through. And all we're going to do is cut the interior features. So I realize your part's going to look different than mine. Okay, we're doing this project on a water jet, and we actually have to do something in this software. HSM doesn't include the water jet, plasma, and laser package in the version that runs in SolidWorks. That was news to me. I thought it was available for all three platforms, Fusion 360 and Inventor. Apparently it's available in Fusion 360 and Inventor. So if you choose to, you want to use a tool that's more set up to do those types of operations. I've also included a Fusion 360 version of this tutorial, but that'll require you to download Fusion 360 and establish an account. All the other functions appear to be in HSM, so the rest of the semester we'll be using HSM. From what I gather, if you have a laser, water jet, or plasma cutter, you use the milling portion of HSM in SolidWorks, and then you have to tune a custom post processor to output the code in the way your machine reads it. Okay, so here we go. We have our part, and we're going to be using CAM here. It's not the SolidWorks CAM or SolidWorks CAM TBM. That is another package called CAM Works, which there's a stripped down version embedded in every seat of SolidWorks now because they bought them out. So the CAM, SolidWorks CAM, is a more powerful package. That's why we're using it for this class. Okay, so we're going to expand out our monitoring plane here, and we want to be in the CAM tab. Okay, we're going to go to the tab here and say job. We're going to create a new job, and the milling type's going to be milling. If this was Fusion 360 or Inventor, you'd have a third option. It would say cutting, and we're going to call this our MONIKER. Plate. And we have the model loaded, and it's asking how are we going to make stock. Relative size box, but we're not going to add additional stock. So it's trying to size up the volume of the model and determine what stock is. So in this case, we're just going to use the 12 by 12 plate, and all the work we do will remove material from within that. So we don't need to add any additional stock. We're not going to add a fixture, and we're going to use a different orientation than what we have shown, and we don't want our stock orientation to be in the center top of the part. What we're going to do is we're going to change this to, we're going to use Z axis and an X axis reference. So our Z axis is going to be the top of the part, and then our X axis is going to be a horizontal line on the part. In my case, the gnome didn't change. Okay, and we're going to set our origin at the bottom left corner of this. So it's going to be stock box point at the bottom corner 3. Okay, we continue scrolling down, and we're going to leave everything else except for the program name. We're going to call it M. Actually, we can't do that. Let's call it 9001, 4-digit number, and we can put in here a MONIKER. And what that does is puts a note inside the code for the name of the file for the operator to see. We're going to accept that job, and now we have that set up. Now if we scroll all the way to the right on these tabs, there's 3 of them that look similar. These first 2 are for CAMWorks. This last one is for HSM. So we're going to select on that. It's a menu tree specific to HSM. Here's the job we've created. We need to highlight that job, and now we're going to create operations. Okay, so we're going to go to 2D milling, 2D contour, and we're going to go to our library. Okay, and we're gonna right click, and we're gonna add a library folder. And you want to make sure you save that in your H drive. Otherwise, the next time you come to work on this, it won't be here. So in my case, it's just going to go to my documents, okay, my libraries. But you want to make sure that you create this folder in your H drive. Okay, so this is going to be S60. Okay, is the library. Okay, so this new S60 folder, you need to make it in your H drive so that everything we create stays in that library. Alright, so what we're going to do is we're going to create a new library, and this is going to be our S60. S60, and we're going to make a new milling tool. Remember, we're going to fool HSM that this is actually a water jet. So it's going to be tool number 1, length offset 1, diameter offset 1. Just leave that all at default. We want it to be a live tool, which means it spins. In this case, it's not spinning, but it's going to put a pressure in instead of an RPM. And we're going to call this the Wazer .044 inch nozzle tip. We're going to say Wazer, the vendor is Wazer. And if you had a website, you could put the product information on there for that actual tip. Okay, so now we're going to go to the cutter, and we need to match it to that. So we said it was a 44 thousandths kerf. So our diameter is 0.044. Okay, and we're going to put in some kind of bogus information, but we're going to say the overall length is 2 inches, and that the body length is 1 inch. And we'll say that the flute length is 0.25, and our shoulder length will be 0.75. We'll put a shaft diameter, which there really isn't a shaft on this, but we'll set it a 1/2 inch, and our shoulder length at 0.75. So graphically, we're going to see this thing like this. What's really going to output on the machine is that the end of that tip is actually going to be a stream, high pressure stream of water. Okay, we're going to hit OK. And that's our simulated Wazer tip. Okay, now that we have that tool made, we can select it from the menu. And we're going to ignore all the feeds and speeds in this case. Again, they're going to output as pressures, not RPMs, and feed rates. we're going to go over to what features on the model are we going to machine. So we're going to select the bottom edge of the circle, the bottom edge of my ice cream cone shape there. Now you may have more features than I do, so you may need to select more items. We're not going to cut the outside periphery because that's already cut, 12 by 12. And we are going to leave all the rest of these at default. We're going to go to heights. These are different planes that denote different levels. So there's zones, which changes how the behavior of the cutter is. So the clearance height is usually a plane that's above any clamps. So it's calculating that is the clearance height is 400 thousandths from the retract height. So if you go to the next box, the retract height, which that number is based off of, is 200 thousandths from the top of the stock. And that's an area where when you're down within the work, it's going to retract to do local work, but it's not going to pull all the way up to avoid a clamp. And then we have our feed height, which is this, can be this, in this instance is the same. That is where it's going to move from rapid, which is as fast as the machine can move, to a known feed rate. And so that's 200 thousandths also from the top of the stock. Oh, it's from the top. And the top is set as the from the top of the stock, which it is. And our bottom cut is to the contours we selected. So it's going to cut all the way through to that layer. We go to the next tab. We're going to do 2D contour. The compensation is going to be in the computer. And we're going to basically take all the rest of these on default, except we're going to check one down here called smoothing. And what that does is on curvatures, it makes a tighter tolerance, so you get a smoother contour. Now we're going to go to the last tab, which is linking. And we're going to leave the top stuff at default. You want to keep the tool down so that it doesn't have to pull up when it's within 2 inches of the last cut. And then we're going to set these lead-in and entries. So we're going to put in a lead-in radius of 0.06. And 90 degrees. Our extension is going to be 0.06 and perpendicular to the path. And we're going to set the vertical radius to 0. Now, if you have features that are a lot smaller than mine, these settings may not work for you. It may cut partially and not cut all your features. So you may need to reduce those numbers that I just plugged in related to the leads and transitions. Okay, we're all set. We're going to hit the accept button and we generated our toolpath. Now I zoom in and we've got, I think I'm zooming in. It looks like we have a problem here. Okay, so our cutter path is on the inside of one, but it appears that it may be on the outside of the other, so this hole is going to end up being too big. What to do? Well, let's go back, check our geometry selection. If I go back to geometry and I look at what I selected, and then I'm going to select reverse, and it's going to default to selecting the first entity, and as you can see, it flipped the side that entity was cutting to. And next we're going to do a cool feature called stock simulation, which is going to simulate the cutting. So we hit play and it actually shows the cutter moving through the material as simulating the stock. So we're moving around. It's giving the toolpath coordinates on the lower left corner. And we're cutting out the ice cream cone shape. And then it's going to pick up and it's going to rapid, turning the water jet off over the circle. It'll come to unpierce, ramp in, cut the full diameter. And ramp back out with a radius. There we go. We're going to exit this. Okay, now that we've simulated, we need to make sure we save. And now we're going to post-process. So you need to highlight the entire job. We're going to select post-process. And we're going to select, first you need to go to setup up here. And you're going to pick on the little box. Pick on setup, and we're going to use the installed post libraries. Okay, you're going to select that option, and then we're going to select Fanuc or Fanuc, depending on how you want to pronounce it. Fanuc, it's a well-known control manufacturer. And then you want to make sure that your output folder is going somewhere where you can find it, so it should be your H drive. So if it doesn't show that, change this directory to where your H drive is, because you're going to be looking for an output file with the .nc extension. Okay, we've got our program number and name as if we typed in it before. If this box says automatic, change it to inches, and make sure the box this is open an NC file in editor, and that way it'll come up on the screen when it's done post-processing, and you'll actually see the code. So I'm going to hit post. I'm going to accept my location here. Okay, and then you're going to take, this is the actual code file that was output by your programming. Okay, so we have our 2D contour. It's called MONIKER plate. We've got a bunch of code. And it's just one contour, so pretty quick. So we can close this, and you're going to upload the file that says 9001. That's going to be uploaded in your MONIKER assignment. Okay, that's it for this tutorial. I'll catch you on the next one.